So first day of chapter 7, conic sections. Lesson 1 is looking at parabolas, and we're on day 1. And one of the algebraic techniques you're going to need to do is to complete the square. To get equations, this here is the equation of a parabola, but it'd be impossible to graph from that form. You want to get it into what we call graphing form or standard form. When you're in algebra 2, you probably called it vertex form. Now, the way you do that is you use this technique called completing the square. So what you do is you'll add something to this side that would make this a perfect square, so it could be factored. So you could write it as x plus something squared. And that would help you know whether your parabola is shifted left or right, yeah? And there'll also be other stuff. This isn't a full parabola. This is an easier example. This one's going to become more interesting down here. So before we actually get on to complete the square, how many of you actually know what number we'd put in there? Type into chat if you happen to know what number goes there. Let's see. So let's first of all look at what we mean by writing something as a perfect square. What we're going to do is we're actually going to start with a perfect square and go back to what it would look like as a trinomial and see if we can work out the pattern we'd use. So I'm using a totally different example here. If you had x plus 5 and you needed to square it, that would be x plus 5 times x plus 5, and let's FOIL it out, yeah? It wouldn't simply be x squared plus 25. I hope you're not thinking that. The first term would be x squared. Your outer would give you 5x, and your inner would give you 5x. You get 2 lots of 5x. And then your last term is plus 5 times plus 5. It's plus 5 squared. Now, obviously, we don't write it like that. We would write it as x squared plus 10x plus 25. And that, in factored form, is this. So when we're completing the square, we're just given the x squared plus 10x, and we're having to work out what we are adding. And when in factored form, what number do we have here? It all comes from this. And this number was 2 times 5 times x. So 2 times 5, there's your 5 here. The number you've been given here, you work out what goes down there by getting this number and doing the opposite of multiplying by 2, you divide by 2. So you do 10 divided by 2, gives you 5. And then you get that number and you square it and put it in the extra box, okay? So if you had, ax squared plus bx plus c, we can only complete the square if our a is positive 1. So we've got a number there, we actually have to factor it away. If we have x squared plus bx plus c, we get that value and we divide it in 2 for what goes in our factored form, and this value here will be that squared. So you cut this number in half, bring it down, square it, put it back. Let's have a look at that with this one we were given at the beginning. So the number we're going to add in here is 9. Well, how we got that was we got 6 divided it by 2, which gives us 3, and then we write 3 squared in there, and we just write the 3 down here. Now, this is an equation, it's equal. And if something is equal, and you suddenly add like a weight, heavy weight, like 9 on one side, it's no longer balanced. So to keep it balanced, if we add 9 on that side, we also have to add it on this side as well. So writing what we were given as a perfect square, we'd write x plus 3 squared equals 19. We're adding those together. Okay, so this is the equation of a parabola. That's what our lesson is about today. But we have to get it in some form where we can graph it. when you were in Algebra 2, you would have called that vertex form. See if you can work with that for a second while I check who it is who's trying to come into the meeting. Okay, so the first thing you want to do is when we have it in vertex form, we have all the values of the variable that's being squared. We have sort of like anything to do with x squared on one side, and we have our y's on the other. So what you want to do is you want to look at your equation and move all, this one has got x being squared. Sometimes we have y being squared. So we want all terms with x, all terms with x on one side of the equals everything else. So I've actually done this for you. So this minus 12y and minus 21 have been moved to this side, and they become plus 12y and plus 21. Okay, that was the first thing to do. Then to complete the square, remember I said you can't do it if your square term is being multiplied by something. If it's got a coefficient, you have to factor that out. So what we're going to do is we're going to factor that 3 out from x squared and out from that 6x as well. So this will become 3x squared plus, factor the 3 out of that 6, it becomes 2. And then we're going to leave a space to complete that perfect square so we can turn it into, we can factor it. And anything we add on that side, we're also going to have to add on this side. So what do we add? This number here, we cut it in half. 2 divided by 2 equals 1. That's what goes in our perfect square. And then we square it and put it back. 1 squared is 1. Now, because we added that to the left of the equal sign, to keep this in balance, we have to add the same thing to the other side. So what am I really adding on there? I've got a 1 in the box, but look, we didn't just add 1 on this side. That was in parentheses, and that 3 would get distributed to it. So we've actually just added 3 to the other side. So on the other side, no, by the way, that's format. We've got 3x plus 1 all squared equals 12y plus 21 plus 3 is 24. To graph it, we want it in the form of y equals something. So let's subtract 24. And we just want 1y, so to get cancel out multiplying by 12, I'm going to divide by 12, divide by 12, divide by 12. Okay, so this leaves me with y on this side, minus 24 divided by 12, that's easy. Now this part here, you could say that, but that's going to make graphing much more difficult for you. That would be much better written as 3 divided by 12 reduces to 1/4, multiplying by that. Okay, so that's how you would have been given it in Algebra 2, except, oh, we would have been nice and written it the other way around. Oh, I thought that was minus. I lost a minus there somewhere. I thought this was negative. Well, it's not negative. Okay, right. So that's the Algebra 2. Is that worrying you? That means you know it's going to change. That's the Algebra 2 vertex form. In pre-calculus, we change it just a minute bit, but let's see what you're familiar with that for now. Take 2 minutes and write down everything you could think about that you know about that parabola. A good way to do that would be to attempt to graph it. Try and graph it and see if you can, what you can remember. Okay, so in vertex form, that implies to you that a parabola has a vertex. Now, this will have moved it left 1, and that will have moved it down 2. So you're going to have a vertex at -1, -2. Label it V for vertex, okay? And then you look at this minus and the fact that it's x squared. Now, there's a lot you could memorize in conic sections for pre-calculus, and you want to try and get away from just memorizing, because you get very confused if what you're doing is memorizing. All I think about is in Algebra 1, you learned that. And that was the happy parabola that opens up, yeah? If it was negative, it opened down. And then in Algebra 2, they said, oh, you can't just square x's, we could square the y instead. And I hope you learned that that one opens to the right, and x equals -y squared opens to the left. So what you look at which is your variable that's being squared and is your coefficient. Doesn't matter if it's on the left or the right, whatever you're multiplying by, is it positive or negative? Because we're based on -x squared, that's going to tell us that our parabola opens over the negative x-axis. It's going to open to the left. Okay? And looking at this, we've got negative, oh no, negative x squared. That one. Ours is going to open down. Good grief. Okay, now, so the other thing you looked at in Algebra 2, you said probably said that's a vertical compression by a quarter, which makes it wider. I hope you remember in Algebra 2, you probably looked at that and you called it something called 1/4p. You said that coefficient, 1/4p is 1/4. So you know that p must be 1, yeah? If 4p equals 4, then p must equal 1. Now, what was that for? It told you something called the focal length. And that told you where a point called the focus is. It's going to be down, because the parabola opens down, by this length. So from the vertex, we go down 1 point, and we get this point called the focus. If we've moved down, the y coordinate will go down. Okay, we're going to go down by p, the focal length. Now, there's many parabolas that could open down going through this vertex. You could have a skinny one, you could have a wide one, you could have a super wide one, yeah? So when you've got this vertical compression, it makes it wider, but there's a much easier way of thinking of it than thinking of it as vertical compression. We have this thing that's called the focal width. I hope you're writing these notes. That is how wide the parabola is at the focus, how wide it is from side to side. Okay, the proper name is not the focal width. We call it the focal width at Tompkins because some teachers are a little bit too embarrassed to say this. Its real name is the latus rectum. And a lot of teachers don't like saying the word rectum in class. True, it's true, they really don't. Now, the width of the parabola through the focus is actually going to be that distance 4p that you wrote here. So it's going to be a distance of 4 wide. Imagine you've got this shape. If it's 4 the whole way across, then you're going to go 2 to the left and 2 to the right. So there's my parabola there. That's how I know how wide it's going to be. There's a few more pieces of information you need. You need something called the axis. We sometimes just call it the axis, but it's the axis of symmetry. and that goes through the vertex and the focus. That's your axis of symmetry. An easy way to get the equation of that is to look at your vertex and your focus and say what's the same about them. Well, I'm seeing -1 in both of them, but don't just say that, say x is -1, and that gives you that equation. The equation of that line is x is -1. You also have one other really important point. It's not a point, it's actually a line, another feature. It's something called the directrix. And we'll talk about that a little bit more tomorrow, what the directrix actually is and what it does. If the parabola opened down, the focus was down by p from the vertex. To get the directrix, you're going to go in the opposite direction. So we're going to go up by p, and our p is 1. Okay, so we go up 1 from the vertex, which will take us to there, but the directrix is actually a line. So I'm going to do a line through that point. It's perpendicular to the axis. And that's the equation. You can see it's down 1. It's y equals -1. We've moved down 1 from, oh, no, up 1. Sorry, we went up on the vertex. Up 1. You moved up 1 from that, you get to -1. Y is -1. So a lot of that should be familiar. What this is part of, what we've just been looking at there is parabolas. Now, the whole of chapter 7 is on things called conic sections. Can you see why they're called conic sections? Section is a medical term, like when you dissect something, you cut it, you slice into it. Some women, when they have a baby, have an operation, I think that's the most operation a lot of people have heard of, called a C-section. A section means you slice into something. Now they're cones, that's why they're conic sections. Can you see that these are 2 cones, one on top of the other? And if you slice through it, you section through it at exactly the same angle as the slope of the sides, the shape of the cut surface, the shape of the section is a parabola. If you had a cone and you cut exactly horizontally through it, the shape you'd be looking down on there would be a circle. If you cut it at an angle, but the angle wasn't quite as steep as the sides of the cone, you're actually going to get a misshapen circle called an ellipse. You saw one at this point, you probably call it an oval, but its proper name is actually an ellipse. And the last one is the most fascinating shape. Okay, mathematically the most difficult is hyperbolas, but by far the most useful. All of these shapes have got incredible real-life applications, but this one, I don't think anyone in the modern world could survive without it. The math behind hyperbolas is all the math behind global positioning systems and use of, like, whenever you're using Google Maps or anything like that. Everything behind that's the math behind hyperbolas. And I'll tell you a bit more about that when we get on to them. But for the first few days, what we're going to look at is parabolas, and these are going to seem quite familiar. So I have one disappointment for you, though. You know, I said it was all based on what you saw in algebra. Let's see. In algebra 2, you called this 4p. Some textbooks call it P in pre-calculus. Some textbooks call it A. And at Tompkins, we're not going to call it 4P, we're going to call it 4C. The focal length that you used to call it P, we're going to call it C. And some textbooks call it A. Well, it's just a length. You need to know what it is, don't get hung up on the name, but we are always going to refer to it as C. So, here are almost what you would have seen in algebra 2. You would have got this: y equals 1 over 4p, but we're going to call it 4c, x minus h squared plus k. But that's how far you went left and right, that's how far you went up and down. Now in pre-calculus, no one puts the K over there. K is to do with horizontal movement, so we subtract it and we vertical movement and we put it with the K. Now, if you see minus K, you're going to go up by K. It's together with the Y. And so it actually works exactly the same as you're used to doing with X's. It's going to go the opposite way to what it looks like. We're going to put it on the same side of the equals as the Y. Yeah? And we're going to call this 4C, not 4P. That's how we do it at Tompkins. That's the OTHS pre-calculus form. Most textbooks don't do it like this, though. They cancel out dividing by 4C by multiplying both sides by 4C. And in your textbook, you're going to see this. That's what you're going to see in the textbook. Now, it's really not that bad. Really, it's not that bad. That, to me, is much easier to look at than that as well. It's all linked. So this one, where x is being squared, is either going to go open up, or if you've got a negative coefficient, doesn't matter if the coefficient is negative here or if it's negative here. Still, you're multiplying by something negative. Okay? It's going to give you, look at that. It's going to open down. If your y is being squared, you're going to be opening that way. If it's a positive coefficient and a y squared, if you have a negative y squared, negative coefficient y squared, you're going to open to the right. You're going to work out this length of C, your focal length. And you're either going to go left, right, up or down. So you're going to go right to get to it there, left to get to it there, up to get to it there, down to get to it there to get to your focus. And then your width is going to be 4C going across. So there are plenty of notes on these that you could memorize. I don't want to spend class time if you're writing down notes. These are the notes, and I'm going to take a screenshot in a second. Let me clear everything up. And you can take a screenshot of this. Let's do it so you can see the whole screen. Okay, so you could take a screenshot of that, and that's the notes for a vertical parabola. And you could write them out if you want to. So this width through the focus, we call it the focal width. On anything online, if you go for online help or anywhere, they're going to call it the latus rectum. They're not going to call it the focal width. It's the width of the parabola through the focus. This dimension 4C, that's in the equation here or here. Sometimes you're going to see it referred to as 4A. Sometimes you're going to see it referred to as 4P. We refer to it as 4C. Okay. Now, how do you know whether the coefficient you've been given is 1 over 4C or whether it's just plain old 4C? The way I look at it is, because sometimes you can't just say it's a fraction, so I've been given it in this form. Because sometimes C itself is a fraction, and this will look like a fraction. You need to know whether you've been given 1 over 4C or just plain old 4C. How I think of it is 1 over 4C is more complicated. Than 4C. If it's on the side that is more complicated, something squared is more complicated than something not squared. If the coefficient you're seeing is on the side that is not squared, the coefficient you have been given is in the form of 4C. If the coefficient you're seeing, because it's just going to be a number, is on the side that is being squared, you've been given the coefficient in the form of 1 over 4C. And you're going to need to get used to that. Okay, so those would be notes for a vertical parabola. I'm not leaving you time to write those in class. You may print them off or write them in your own time. And here are the notes for a horizontal parabola. Okay, same thing. I'm not going to give you time because I think we need to focus on actually practicing some examples of this. So let's go. Let's do some graphing. Here we go. We'll graph one here that's being given sort of in Tompkins form. Often, sometimes you'll see that in parentheses. So the first thing you want to look at, well, I guess the easiest thing to look at is where is the vertex. This has been moved left 1 and up 3. Remember, you're always doing, when they're in parentheses like this, you're doing the opposite of what you see. Okay, that's where your vertex will be. And now we have to decide which way is it going to open. So to know which way it's going to open, I just go and glance at it and see which is being squared. Is it x that's being squared or is it y that's being squared? Well, it's y that's being squared. And then go and look at your coefficient. It doesn't matter which side is it on. Our coefficient is negative. So we've got negative y squared. That's going to tell me which way it opens. And in my head, I'm just thinking this one thing. Well, I know that opens up. This is y squared. So it's not going to be up, down at all. It's going to be left, right. And it's minus, so it's going to be that one. It's going to open over the negative x-axis as opposed to the positive x-axis. Okay? So this is telling me, because it's negative y squared, it's going to open left. Then I have to know, to get to the focus, I'm going to move left by the value of c. So I have to work out what c is, my focal length. So now I look at the coefficient, I just the absolute value of the coefficient, I'm not caring about that negative anymore. And I look at that and I say, have I been given 1 over 4c or have I been given 4c? Have I been given the complicated form or the easy form? I'm on the complicated side, so I've been given that form. 1 over 4c equals 1 over 8. So what must c be? C must be 2. 4 times 2 is 8. And 4c must just be 8. Okay? Let's get this extra junk off here. So to get from the vertex to the focus, let's graph that vertex. -1, 3. Label it with a V for vertex. That's really quite important. I'm just going to go left 2 places. 1, 2. That's my focus. You can do it algebraically. If I'm moving left, would my x change or my y change? It would be the x. And if I'm going left, that's going to become more negative. By 2, it will become -3. Look at that point I just plotted. It is -3, 3. To get my axis of symmetry, just look at those points. What is the same about them? 3. What is 3? Y is 3. That gives you the equation of your axis of symmetry. It's a line that goes through those 2 points. Okay, if I moved left by C to get to the focus, to get to the directrix, I'm going to move in the other direction by C, and our C was 2. So from the vertex, I'm going to go 2 to the right, which would take me there, but the directrix is a line that goes through that perpendicular to the axis. That's my directrix. And you can see it's going through x is 1. Or you could say I'm going right at that by 2, by C. I'm adding 2 to that, which gives me x is 1. Okay, so my directrix is x equals +1. The last thing I've got to do now is to graph the width of it. How wide is this? Now remember that we call that the focal width. We're going to have to really be clear which is focal length This is focal length. This is focal width. Your focal width, remember the proper name for it, is the latus rectum. And it's the 4C, so it's 8. And that is basically telling me, I've got this parabola opening to the left. It's telling me the width through the focus is 8. So I must have to go 4 up and 4 down to get a width of 8. So from the focus, I'm going to go 1, 2, 3, 4 up, 1, 2, 3, 4 down. That's a total width of 8. And now I can finally draw in my parabola. Through those 2 points. So the only points I've graphed accurately are these ends of the latus rectum and the vertex. I've only graphed 3 points accurately, but all the other information needs to be on your graph. This focus is incredibly important. We need to be able to see from how you've marked up your graph where it is. I've got to be able to look at your graph and know the focus is at -3, 3. I've got to be able to look at how you've marked up your graph and know the directions. It says that x equals 1 and the y and the actual axis of symmetry is at y equals 3. How long have we got? Okay, we've still got a fair amount of time. So I'm going to give you a few minutes to actually practice graphing one on your own. So try graphing this one now. I'm going to give you about 2 minutes, then I'll go over it. So on this one, remember that's with the y, so that's actually going to make it move up 2, and that's going to make it move left 2. So our vertex is going to be at -1, 2, label it with the V for vertex. This coefficient was on the squared side, so we've been given 1/4C, and it equals 1/4. So that's telling me basically that my C must be 1 and my 4C is 4. Okay? So that's giving me my focal length and my focal width. Which way does it open? It's got a negative coefficient and it's x that's being squared, so it's going to open down. So to get from the vertex, from the vertex to the focus, I'm going to go down by this. This is my focal length. I go down by 1. So there's my focus. It's at -1, 1. And to get the directrix, I'm going to go up 1 above the vertex. That's going to be my directrix. So that's at y equals 3. Okay, then I'm going to need to put in the width. This is going to be the latus rectum, or focal width. It's going to be 4 wide. So if it's opening down, so I've got this, and it's 4 wide, I'm at the focus. I'm going to go 2 to the left and 2 to the right. And what have I not put in? I'm missing the axis of symmetry. Goes through the vertex and focus. That's my axis. That's the easy one. Look at these 2 points. What's the same about them? X's are equal to -1. Okay? So give yourself a pat on the back. We've got that one right. Let's try something harder. This is harder. Can you see why this is more difficult? We haven't been given it in graphing form. We're going to have to complete the square. So write that down. And now remember what I said at the beginning. You look at what's being squared. Y is being squared. So get all y's on one side equal to everything else. So I'm going to have y squared. This -6y is going to have to move to the other side, so it'll be +6y. And I'm going to have to complete that square. And I put everything to the other side, so this plus 16x, we'll go to the other side, it'll be negative 16x, and I'm going to have plus that 55 plus something to complete the square. So how do I complete the square? This number here divided in 2 gives me 3. Square it, put it back. Cut it in half, bring it down, square it, put it back. So what have I got on the other side? I've got negative 16x plus 64. Nearly there. I need to factor out that negative 16. So I've got y plus 3 squared equals negative 16. Factoring out the negative 16 leaves you with x. Factoring out a negative, that would be negative 16 goes into 64 4 times. So I'm ready to graph it. This is more in the way you'd see it in the textbook. You could get that negative 16 and divide it away and put negative 1 over 16 on this side, but you don't have to. You don't have to. Okay, you can just leave it like that. That's the textbook form. So we've definitely got a negative coefficient, and we've got y being squared. It's negative y squared. It's going to open left. It's basically going to be that shape. Now, that coefficient we've been given to get 4c, the latus rectum, which we're going to need to find c, we've got our coefficient is 16. It's not on the squared side, so this is 4c. That side is not squared. We've been given the simple form. On this side, it would have been 1 over 16 was equal to 1 over 4c. So 4c is 16, divide by 4, divide by 4. Our c must be 4. So our vertex, it's getting a little lost here. Got too much stuff everywhere. Let's remove some of this stuff. Too much stuff. So this is the equation I'm trying to graph. My vertex must be, the x would be positive 4 and the y would be negative 3. Go across 4 and down 3. That's my vertex. To get the focus, I'm going to move left by my focal length, which is this c. Move left by 4. So the x will change, go 4 to the left. That becomes 0. If you can't do it that way, do it on the graph. Go to your vertex and count 4 to the left. 1, 2, 3, 4. That's your focus. At that point, it's going to be 16 wide. It's going to be 16 wide at the focus, so I'm going to have to go 8 up and 8 down. 8, 1, 2, 3, 4, 5, 6, 7, 8. So there's my parabola. Am I missing some information? Yay, I am. I've got my focus, I've got my vertex, I need my directrix. That was 4 to the left, go 4 to the right. 1, 2, 3, 4. My directrix is that x equals 8, and I need my axis of symmetry, which goes through the focus and the vertex. That's my axis, and that's if y equals negative 3. Remember that one, you can look up here. What's the same about those two? The y's are negative 3. Y equals negative 3. One label is missing. This should be the directrix. Ooh. Well, I can't go onto my board there. That's a directrix. We'll just put a D for directrix. How about that? And it's that x equals 8. Is there enough information on your graph that have you got enough things labeled on the scale that people could tell the coordinate at this point, the coordinate at this point? Did you accurately plot the width of the parabola through the focus? Have you got the directrix? Have you got the axis of symmetry? Now they've labeled that clearly enough that you can see them. Right, I did that bit fast because I had my eye on the clock. How do you find the directrix? Okay, To find the vertex, you went left by 4 because it opened left and your focal length was 4. Whichever way you go to get from the vertex to the focus, you go the opposite way. So get to the directrix, I went right by 4. The opposite of this, yeah? Great question. Any other questions?